We already studied the premixed burning, and starting from the beginning, we look at a stable burning frame, burning premixed frames, and we introduced there is the two most important burning characteristics need to be identified, be used to identify the burning intensity. One is the adiabatic flame temperature. The other one is the nominal flame speed. After that, and we try to let you understand what is the influences coming from the flow convection. Basically, this is the from microscope point of view, and also the Lewis number from the microscope point of view, and give you the idea about the effect coming from the flow stretch. Usually, they couple with the Lewis number. And for this part, we try to use different laboratory frame to give you some understanding on this coupling effect. For example, we introduced the flat frame propagating in stagnation point flow or counter flow, or as we say, post-jet flow. And we use the Bunsen frame to let you know the influence coming from the flow stretch coupled with the Lewis number. Then we shift a little bit to the transient state for premixed burning, and to give you the understanding the S curve described by Danko, which means that we use the Danko number to identify the conditions for ignition and extinction. Ignition and extinctions are transient states for a given premixed burning. Now we go to the other very important subject we need to identify. We look at the stability of a premixed frame, which means we are thinking about if the premixed frame disturbed by some kinds of perturbation or outer influences, and can this frame still can stabilize in the given flow we have. Okay, then we call this as the stability analysis. And from the early beginning, actually Landau did those kinds of analysis on the propagating frames, but they use the terminology and also the methodology to think about this kinds of stability analysis based on so-called hydrodynamic instability. Now let me introduce the hydrodynamic instability first before we go to the real discussion, detailed discussion about the combustion instability. Landau described the hydrodynamic instability. He think about the frame. Basically, they use this is a very important assumption. They completely neglect the frame structure by collapsing the preheating zone as well as the reaction zone into an infinitesimally thin frame front. This kinds of concept actually we already described in the very earlier when we just look at the balance between the far upstream and far downstream. You can use this kinds of consideration. Just look at your frame as a thin zone, but this thin zone include the preheating zone and the reaction zone. As we described the frame structure earlier, we try to separate to emphasize the flow structure in the preheating zone and also reaction zone, right? Both flow structure in these zones are quite important, because in the preheating zones we emphasize the Lewis number effect, the balance between the thermal, the heat diffusion and also mass diffusion is quite important, and those are described by the Lewis number equal to 1 or not equal to 1. But here, Landau tried to analyze the stability for a given premixed frame by consider the frame basically composed of the preheating zone and the reaction zone, and they collapse together as only one sheet. Okay, now try to think about when they collapse the preheating zone and the reaction zone together as a thin sheet, which means the Landau did not consider the imbalance between the heat diffusion and the mass diffusion. Okay, this is the main point. Later on, we will think about the more deep by introducing the so-called thermal diffusion instability. This will be the next part. and we try to emphasize the important inference coming from the Lewis number on frame instability. Okay. Now, when you study the stability for given system, usually we try to give, for example, this system is a stable, exists in some conditions, and you want to check the instability of this system, then the only one, the easier one to examine it, then we usually use some perturbation, try to disturb the system. And if the system, when the system experience the disturbance, system behavior will jump to another state. But if you release the perturbations, usually for a stable system, the system behavior will return to the origin one. If they can come back and still stabilize in the previous status, then the system, we say this is a stable system. But if you apply perturbation into the system, but this system will jump to the other state without have a tendency to coming back. That means that they change from the original state to the other state. This system, then usually we call this is unstable system. Okay, when you have this kind of behavior, we give this system has a small perturbation, then this system jump to the other state, never come back, which means that you have another perturbation. This system will jump again to the other state. Now this system will always be disturbed and change their state, and we call this system is unstable. Okay, this is a basic idea to check the system is stable or not stable. Okay, now look at here. Now the idea is the here for the Landau instability, we call this hydrodynamic instabilities. And originally, you can think about the there is the planar flat premixed frame. Okay, just like as a vertically exists, and just like the one-dimensional flow here. Okay, you have a one-dimensional premixture stabilized at certain position. Okay. Now you try to disturb it. The disturb frame shape is look like this on your lecture notes, and this will be the page 1.26. Okay. Now this frame shape actually is already perturbed by outer disturbance. Okay. And you can see, for example, you look at this frame structures. In the left-hand side, that is the upstream premixture part. Then you can see there is the unburned gases coming from the left-hand side. After the burning, after the chemical reaction, the burnt gas will move to the right-hand side. Okay, the left-hand side is upstream, the right-hand side is the downstream. Okay, usually can be referred to our one-dimensional premixed frame model. Now here, when you think about the problem, is like this. Now, Landau plots the U-tube or the string tube you may have. Okay, for example, you look at the upper part of this figure. In this flow tube, they give you the idea. There is a certain amount of premixture coming from the upstream side, the left-hand side, and then move through the frame region, burnt. Then they go to they follow further to the downstream side as the products. Right? Okay. Now, originally, you have a planar frame, and the planar frame tell you basically the supply of premixture is just balanced with your burning intensity. Then the frame is sit as a flat frame properly at a certain position. But now you disturb the frame as a curve frame. Now this curve frame will give you some influence on your string tube. For example, here, the upper part tell you, since this frame the frame shape is convex to the downstream side, it's just like a mirror, right? Okay, this mirror in the front of the frames, they will have some focusing effect to let your string tube to change their direction a little bit along with the curvature of your frame. Okay, by this kinds of consideration, you can think about for given string tube. What is the string tube? String tube means there is no flow has possibility to move or go across into to the string tube, right? Because all the velocity, the flow velocity is tangential to the string line, you do not have a chance to let your flow particle move through the string tube. All the gaseous particles molecules will be restricted in this string tube. And in a sense, for given total flow rate, the cross section of a string tube becomes smaller, right? Becomes smaller. Then you think about the mass balance. You will realize the cross section reduced. Then your flow velocity will be increased. Okay. Then you move from the upstream side closer to the friend side. You will find out the approaching flow velocity will increase continuously, right? When you have a larger upstream velocity, as we remember, as we define the French speed balance, we say if there is a French sit a certain position, then this at this position we understand the French speed will be balanced by the coming flow velocity. They just balance. But in this case, when you have a curved frame, this curve effect will give you some focusing to reduce the cross section of your flow tube or the string tube, then upstream flow velocity increase. When you have an increased upstream velocity higher than original frame speed, that means the frame will shift their position to avoid to go to the lower approaching velocity part, right? Then this frame will move to the downstream. Okay, this is the first idea you can look at. If we have this kinds of curve frame curvature, frame shape curvature, then you will see the cross section reduced and the upstream approaching flow velocity increase. And this value larger than frame speed, original elevated frame speed, then this curvature that will give you the results to push your frame to move to the downstream, which means the curvature of your premixed frame will become larger, right? Become larger, larger curvature means the disturbance becomes stronger. Okay, this is the upper part. You understand that this is a small disturbance. Originally, you may have a small curvature, but they will continuous to let the curvature become larger and larger, move to the downstream sides. The other way, and you look at the lower part is just opposite effect because the frame curvature actually convex to the upstream sides. And in this, in the upstream of the lower frame, they will give you the idea. Actually, the cross section of your string tube is increased. When you have an increased cross section for given string tube, that means the flow velocity near the frame will be reduced. Okay, when you have a reduced approaching upstream velocity, then you will find out it is cannot be balanced with original frame speed. This frame will be pushed to the upstream side. Okay, and this curvature will become severe. Okay, to convex to the upstream more. And you will find out that if you originally you have a flat frame in the lower part, by this convex shape to the upstream, and this disturbance will be enlarged when you start to have this kinds of outer perturbation. And for this sense, you can see the upper part and the lower part, the curvature of your upper frame or lower frame will be enhanced when you start to from the has a disturbance from outer, and this disturbance will enlarge and enlarge and enlarge again and again. Okay, and they cannot give you have a chance to go back to your original flat frame. Then Landau look at those kinds of analysis, and he gave us the conclusion that the frame is unconditionally unstable to perturbation of all wavelengths, which means it is easier to describe the behavior based on these kinds of instability analysis. They say the premixed frame is always unstable. Okay, when you give a small disturbance to a propagating premixed frame, they will those kinds of frames will jump to the other state, never come back when you remove the perturbation out. Okay, Now, this is a when you look at the structure, do the analysis, and it is quite reasonable to think about. Yeah, if you just try to think about the balance, the friend speed and approaching velocity based on the string tube, the cross section of your string tube change, right? That by these structures, mainly we call this is a so-called hydrodynamic. We are looking at the hydrodynamic influences on the flow structure, on the frame structure. Only then you may have this conclusion. But in fact, so many kinds of premixed frames stabilize in a given system, and they can experience different kinds of perturbation, but the frames still can sit very nicely, and they can return or retain their original frame positions. Now, why is the misunderstanding on these kinds of descriptions? Now we need to jump to think about when when Landau described those kinds of unstable mechanisms. Actually, they did a very big, very important assumption. They tried to analyze the frame behavior based on a thin frame, and this thin frame actually they collide the preheating zone and also the reaction zone together without considering the influence coming from the heat diffusion and mass diffusion. Now, the mixing consideration on diffusion transport will give us some misunderstanding on the instability of premixed frame. Now we try to introduce the diffusion transport on the influence of a stable frame. Then we call this as a thermal diffusion thermal instability. Simply say that will bring up the imbalance of diffusion transport on mass and the heat into our premixed frame. This is the next step. We try to give you a more detailed understanding on stable burning, the stability analysis on stable burning frames by considering the Lewis number effect. Now let me stop here. Maybe we can go to the other video to start to describe the Lewis number effect.